Hello everyone. Let us now discuss today's LeetCode POTD problem. Question number 2762. Continuous subarrays. So here in this question, we are given with zero indexed integer array nums. Now, a subarray of nums is called continuous. Continuous only if there is a condition like let I comma j. Now, let us say there is a subarray from I to j, I plus 1, and so on j. Be the indices in the subarray. Now, then for each pair of indices, I is less than or equal to I1, I2 is less than or equal to j. The absolute difference of nums of I1 minus nums of I2 should be from the range 0 to 2. That means, in simple words, we are given with nums. Now, take a subarray where we got some elements. Now, for every element, if you take out another elements, it will be that if you take the difference with this element to other elements, it should be greater than or is equal to 0 and less than or is equal to 2. So this is the range. Now, subarrays. For example, let me say 1 2 3. This is the subarray in nums. Now 1 to 3 is a subarray. Consider this subarray. This is the subarray of size 3. Now take 1. 1 minus 1 is 0. 1 minus 2 is with absolute difference. Is 1 minus 2 is 1. 1 minus 3 is 2. Now take 2. 2 minus 1 with absolute difference is 1. 2 minus 2 is 0. 2 minus 3 is 1. 3 minus 1 is 2. 3 minus 2 is 1. 3 minus 3 is 0. But if you see clearly, we have 1, 2, and 3. Let me add another element 4. If you take this subarray, if you take this subarray 1, 2, 3, 4. If you take this subarray, now 1 minus 2 is 1. 1 minus 2. 1 minus 3 is 2. 1 minus 4 will give us 3, which doesn't come in the range of 0 to 2. So they gave two examples. Let us walk through those examples. Nums is equal to 5 4 2 4. First thing, I will be writing all the subarrays 5 4 2 4 of different sizes. This is the size of one, and second one 5 4 4 2 2 4, and of size 3 5 4 2 4 2 4. Now of size 4, now of size 4 5 4 2 4. Let me take the subarrays. If you see, if there is only one element, it will be considered. Now 5 will be considered, 4 will be considered, 2 and 4. So the count of subarrays which are having which are continuous will be stored in the count, and we need to return this that count. Now 1 2 3 4. Now 5 and 4. We have 5 and 4. 5 minus 5 is 0. 5 minus 4 is 1, and 4 minus 5 is also 1. Now it would be considered 4 minus 2 is 2. So we'll be taking that subarray. 2 and 4 is 2. Now we have another 3. So adding 3 to 4 will give us 7. 5 4 2. See clearly, 5 and 4 give us 1. 5 and 2 will give us 3. The absolute difference will give us 3. So, as I said, every element, the difference of every element with other elements should be less than or equal to 2 and greater than or equal to 0. Now, this will not be considered as a continuous subarray. 4, 2 and 4. 4 minus 2 will give us 2 and 4 minus 4 will give us 0. So, this will be considered as continuous subarray. Now, it will be 8 as we increment our count. 5, 4, 2, 4. Same case. 5 minus 2 will be giving 3. So, we not consider this one. Now, let us go with second example. Nums is equal to 1, 2, 3. As I said before, 1 and 2 will give us 1, 2 and 3 will give us 1, 1 and 3 also give us 2. So, the count of subarrays 1, 2, 3. 1, 2, 3. As I said, if the subarray is containing only one element, then it will be considered. Initially, it will be 0, now it is 3. 1 and 2 is a subarray. 1 and 2 is a subarray of size 2. Now, increment by 1. 2 and 3. See clearly, 2 and 3 is also subarray which is continuous. Now, it is another subarray. Increment our count. 1, 2 and 3. This array totally is a continuous subarray. So, take that. Now, we will be returning 6 as our output. So, the first thing that comes to our mind when we are asked for this type of questions of subarrays, the length continuous subarrays, then we'll be going through a left and right. That means a two pointer approach, or you can say like sliding window. The first thing which I got through is taking sliding window. Now, let us see how I solved the brute force approach, how I got through the brute force approach. Now, as I said, there will be a left pointer and right pointer for for the array. Now, let us take 1, 2, 3. Let right will be pointing here and left will be pointing here. Now we have left and right. You should see clearly, 1 is the minimum element. The minimum element we got is 1, and the maximum element we got is 3. That means if you take any difference, it would be less than or equal to the difference of maximum element and minimum element. How? Let us see. 3 and 2, it will be so. Let me take this absolute difference, it is 2. Now, 3 and 1 is 2. 3 and 2 is 1, which is lying, which is less than 2. Now, 3 and 3 is 0. 1 and 2 is 1, which is less than 2. So, the thing is, if we are having, if we have subarray whose difference of maximum element and minimum element is less than or equal to 2, then it is a continuous subarray. But what is the problem with this one? Now, we will be initializing from right, will be from 0 to n, and if we got this difference of minimum and maximum element greater than, so let us consider we are at this point, r is at this point. Now we have 4. 4 is the maximum element. Maximum element is 4. Now the minimum element is 1. That means we are taking the difference as 3. That means we will be incrementing our left pointer and it will come to here. Now 4 and 2. Minimum element is 2 and the difference will be 2. So we need to increment our left pointer until we get our difference less than or equal to 2. So we'll be running a loop from right is equal to 0 to n, and if you got difference is greater than 2, we'll be incrementing our left pointer. So you will be getting the code. Now this is the code. So here we are having another loop in a loop. That means a nested loop, which is causing a which is causing us a TLE. Now, how do we remove this TLE? So, as I said, we have got a TLA and we are going through a nested loop. We need to remove this inner loop, of incrementing our left pointer. So if you come across that intuition of removing this left pointer and using another data structure uh, for calculating the minimum and maximum element, we will be solving this question. Now, what is that thing? What is the data structure? Let us say we have maximum elements and minimum elements. Let me say it is maximum elements and these are minimum elements. Now, in maximum elements, we will be storing 4, 3, 2, 1, and so on. In minimum elements, we will be storing 1, 2, 3, 4. That means the maximum element of the subarray which we are considering, that may be 1, 3, 4, 2, and 10, 9, 8, like this. If this is an array and we are considering this subarray, then we need to get this one in the minimum element at the first position and in the increasing order, and in a data structure we need to get the maximum element to the minimum element. So that means if you see clearly, we can use a deque. Instead of using a queue, we'll be using a deque, which we can go from which we can remove or add elements to our data structures from the beginning or from the end. So this is the best use of deque. Now, how do we go through the approach? How do we go through the approach? Now, there will be two queues, minimum deque and maximum deque. Now we will be having minimum deque and maximum deque. The approach will be same, but we will be removing the inner loop. As I said, there is a sliding window approach, but we will be removing the inner loop. Instead, while so this is the outer loop for right pointer, while if the nums of minimum deque dot back, that means in the minimum deque we will be storing the index of the element. Instead of the element, we will be storing the index of the element. Now, nums of minimum deque dot back, that means if the back element, that means the minimum element, the last element is greater than or is equal to nums of right. So if this is the case, then we need to remove that thing, remove the last element. As I said, we need to initialize our deque, we need to store the indices. Let us consider we have the nums of right as 4, and the deque, the last element in the minimum deque is 5. Now, if this is the case, so this is the deque and we are having 1, 2, 3, and 5. Now, if this is the case, then 4 should be coming after, uh, sorry, before 5. That means 4 should be before 5. Now, that's why we'll be removing all the elements which are greater than this element, nums of right. For your understanding, I am taking the elements, but we will be storing the indices of the array now. And after taking out the maximum elements, we'll be pushing back from the back this element. So that means we are pushing indices, so it will be easier uh, to compute. So the same will be done for maximum deque. As I said, in maximum deque will be coming from 10, 8, 7, 5, 3, 2. In this way, from increase in decreasing way from maximum to minimum. Now, after removing these things, we will be removing the elements which are greater than nums of right in minimum deque and which are lesser than the nums of right in maximum deque. After removing these, we will be pushing back our nums of right. Sorry. As I said, only the index right will be pushed back into minimum deque and maximum deque. But so let us consider this example where we will be storing the indices of the minimum elements in minimum deque and maximum elements in maximum deque. Now, minimum. What is the minimum one first? 0, 1, and then 3. So, the indices, we will be storing the indices 4, and then 3, and then 2. Now, in the maximum order 2, 3, 4, and 0. So we are having the left pointer at this element, and if you take this difference 1 and 5 will be exceeding 2. The difference of 1 and 5 is 4, which will be exceeding 2. So we will be incrementing our left pointer. But while we are incrementing, we need to consider the thing that if it is less than this pointer, this left pointer, as we got this one 1, now left is 1 but 0, we are having 0. Now the minimum one is 1, so we need to remove this from the front, and we got the minimum one as 1. That means as we remove the left pointer, incrementing the left pointer, as we shrink our window, we need not to consider this one. So this one we need not to consider in our minimum deque. So this is the way, and you will be getting the code in few seconds. If you like this video, share to your friends and like, and do subscribe. Thank you.